at basic graphs where we have no horizontal translation and vertical translation. And then we're going to deal with adding the horizontal and vertical, which makes it quite a bit harder. Okay. So example 3, find a possible equation in terms of y equals a sine b theta. Now, you help me. What does the a represent on any sinusoidal graph? The amplitude. Now, remember a basic sine graph starts at 0, 0 and goes upward, correct? So what if it started at 0, 0 and went downwards? What would that tell us about the graph? A is negative. There was a reflection in the x-axis. Okay? Now B, what does B come from on the graph? The period. So we know that we can get the period if we have B off of an equation, and we can get the B for the equation if we have the period off the graph, right? They're interchangeable. So our formula was P equals 2 pi over B, or P equals 360 degrees over B. Which one would you choose? Well, you'd have to look at the x-axis. If the x-axis on the graph is in radians, you'd use the radian one. If the x-axis of the graph is in degrees, you use the degree one. So technically, if we were solving for B instead, we could bring the B up by multiplying and bring the P down by division, right? So the other formulas we'd have is B equals 2 pi over P, or B equals 360 degrees over P. So if we need B for the equation, we need P off the graph. We need the period of the graph, right? If we have B in the equation, that will tell us the period, correct? So they're interchangeable. You need one for the other. All right? So if I want A for this graph, I want the amplitude. What's the amplitude of this graph? 3. Because the amplitude definition is half the distance from the max to the min or the min to the max, right? So what's the distance from the min to the max in this case? 6. So my amplitude is 6 divided by 2, which is 3. And if I always count the distance, it's always going to be positive, which the amplitude is positive. The amplitude is always positive, but is our A value always positive? No. In this case, we believe it is, okay? So we're going to say y equals 3 sine b theta. We need to figure out what the heck our b is. How do we get our b? Our b value comes from the period of the graph. Now, I want you to write this down and remember it for life. B does not equal the period. The period does not equal B. You use them to find each other, but they are not the same thing. So if you go and get the period off the graph and you plug it into the equation, you were wrong. The equation is B. The equation is not period. Period and B help each other to find each other, but they are not equal to each other ever. Okay? So don't mix them. You need them to find the other one, but they are not each other. Okay? So you never take the period and put it in for B. If you do, that answer will be on your diploma. That is #1 error. I know for a fact. Okay? So, how do we find the period? What's the definition of the period? How long it takes to repeat itself. So you can start in varying different places, whichever is easiest. I'm going to start at 0, 0 and see if it helps. Okay. So I'm going to go past a max, past a min, back to that same height. And what's going to happen after this? It repeats. Could I have done this? Could I have went from a max to a max? Yes. Could I go from a min to a min? Yeah. Could I go from some random place here, past a max, past a min, back to that random height? Yeah. Would it be helpful? No, because I don't even know where the heck those stop horizontally. The period is the horizontal distance it takes to repeat itself. Nothing vertically, because vertically doesn't tell anything about how long it takes horizontally, does it? So, awesome. Need to plug that in. So, when does this repeat itself? What are those ticks? 90, 180, 270, right? How long does this one repeat itself? Every 180. That's the period. The period equals 180 degrees. Remember, the only place you're going to have degrees or radians in the equation is your C value, correct? So if you go put 180 in for your B value, you know you're wrong. The only place a degree symbol or a radian symbol can ever occur on that equation is in for C. So if you go, hey, 180 is B, and you put it here, can B even be a degree? No, that's a hint, you're wrong, okay? So we have the period, we need B. What do? We just take B and we set it equal to 360 divided by P. So what's my B? 2. Now, does that make sense? What is the actual of a normal sine graph? How long does it take to repeat itself? 360. This one has a horizontal stretch by a factor of what? What's my B? So what does it have a horizontal stretch by a factor of? 1/2. So it went from 360 and now it's going to be half of it. 1/8. Oh, we're right. Okay? So your transformation should help you in this situation. Now, how do we know if we're actually right? We set our window to be the exact same window as this graph. We type in our equation and we make sure it's in what mode because this graph is in what mode? Degrees. When I am done, it should look exactly the same because I'm going to make my window exactly the same. If you make your window kind of not the same, you're going to be like, yeah, I think it's right. Why would you do, yeah, I think it's right if you're doing all the same steps? Why wouldn't you make sure it's right? Make it the exact same window, type it in, it should look exactly the same, right? A little replica. So go to your graph in your calculator. What's my Y min? Negative 360. What's my Y max? Oh, my Y min. Oh my gosh. X min, negative 360. X max, 360. What are they all going up by? Nope. What are they all going up by? The second tick is 90. So what's the first tick? 45. They're going up by 45s, guys. So we're going to put an X scale of 45, just so that your ticks are in all the same spot. What's your Y min? Negative 4, if you want to have it exactly the same. Negative 3 is going to touch the bottom of your screen, and then you might be like, no, I'm wrong, right? You want to make it exactly the same. So negative 4, what's my Y max? 4, what's my ticks going up by? 0.5. We're doing everything the same. We're going to go to our mode, and we're going to make sure our mode is in degree, because we're going to push the button sine, correct? We're going to press the sine button. If we press the sine button, we need to be in a certain mode. So we go into Y equals, and we put in 3 sine 2 theta. Three sine 2 theta, close brackets. My window was negative 360, 360, 45, negative 4. Ooh, that's not negative 4. 4.5. Mode, degrees, graph. Is it the same graph as what's in front of your face? Yes. What happens if it looked like the same graph, but the bumps were in the wrong spots? Like a valley is where a hill is, and a hill is where a valley is. What's that a hint? There was a reflection of some sort. Either it reflected horizontally or it reflected vertically. So it reflects above the X or above the Y, and often it's the X, right? Okay. You guys try this one. No. Okay. Used to be in my day, yes. Okay, Y equals A cos B theta. So A, what's my amplitude? So it's 2 and then 2, so 4. 4 divided by 2 is 2. Now, is my A positive or negative? Well, let's think about it. When I drew your basic coast graph, you had a max on the y-axis, didn't you? You had max. It was at 0, 1. Do you have a max right now? No, so it must have been flipped. So my A means I have a flip in the x-axis. It's just same transformations as normal, right? So my A is going to be -2. Cos, how do I find my B? Well, from a max to a max, this graph is what? 720. So you're going to do B equals 360 divided by 720, which is a half. Does that make sense? You're stretching it horizontally by a factor of 2. It's normally 360. It's now 720. Boom, you're right. Okay, plug it in, make sure it's right. Okay, if only the world stayed that way. Let's move on to the next lesson, which adds transformations. All right. It doesn't just stay with A's and B's. We also have C's and D's. Okay. Remember, you always have vertical, horizontal stretches, translation. Yeah. Okay. Is this with the X? You know what cracks me up, but also doesn't, but also makes me laugh every single time? Okay, this is what people do on the test. I'm going to do this in a black color, so it's a little less noticeable, like your pencil. They do this. And then they say to me, when they get their test back, that is a horizontal translation 3 left. And I say to you, no, it's not. There's brackets. And I'm like, yes, there is. But are those brackets typed brackets, or did you put them there? They're like, well, I put them there, but there's brackets. And I'm like, yeah, okay. Yes, there are brackets. You put them there. We agree. So is that actually a horizontal translation? And they're like, yeah, there's brackets. And they're super mad at me. And I'm just like, if I erase these brackets, are there still brackets? No, but there's brackets before you erase them, so it's a horizontal. I was like, dude, you put the brackets. So don't put brackets when there's no freaking brackets, because there's no brackets. So it's not a horizontal translation, and you're like, yeah, I'd never do that, and then you're going to, and we're going to have the same conversation. I'm like, remember that day when I said, and I'll bring up the podcast, and I'll play it for you, and you'll be like, ah. So don't make me do that, okay? This is not a horizontal translation 3 to the left, because there are no brackets. This is what? Vertical translation 3 up. Total different ball game. We agree? Okay, now let's think about this. Our amplitude, we agree, normally has been symmetrical about the x. We agree? Okay, so whatever our amplitude was really easy. We just went up that much, we went down that much, we had our range, we had our amplitude. Life was so good, graphing it was beautiful. Okay, but now we're taking that normal y equals 0 line that we've had the whole time because our d was 0, and we're actually moving that line 3 up. Bless you. Right? We moved it 3 up now. So now our amplitude starts at 3 and goes up that many and down that many. We agree? Okay. Our amplitude is still 1, but instead of it now being a max at 1 and -1, our max is no longer there. We moved that lovely line that was normally here, correct? It's now at 3. It's here. This is our midline. Our d value gives us our midline. So our midline is actually at y equals 3 this time. It's the same as our d value. We agree? And now our amplitude is still 1. It didn't change. Our amplitude is still +1. That did not change. But our range will change, will it not? It's not going to be at 1 and -1 now. It's going to be at, we move up 1, what's our max going to be at? 4. And what's our min going to be at? Wow, I really went up more than 1 there. It's going to be at 4. And our min is going to be at 2, because 1 down from 3 is 2. Yes. So our range is going to be from 2 to 4. It's always min to max. Didn't change. The amplitude didn't change, but our midline, that middle part of the graph, moved up. So our range changes. We agree? All right. Now, what's the period of this graph? The period is based off of what? An equation. The b value. The b value gets the period. The period gets the b value, right? What's our b value in this case? Has our graph been horizontally stretched at all? So what's our period? Yeah. Or 2 pi, depending on what it is. What about our domain? XER, or negative infinity, positive infinity. So for this one, I'll do interval. Does that moving it up affect my x-intercepts? Does it moving it up affect my x-intercepts? Yeah. This graph doesn't have any. It floats from 2 to 4. 2 to 4, 2 to 4, 2 to 4, 2 to 4, 2 to 4. Where's my x-axis? Down here. 2 to 4, 2 to 4, 2. No x-intercepts. That's actually the best thing ever. I don't have to give general solution. I don't have to give any solution. I have no x-intercepts. So it does affect it. So it's circle the ones that have changed. My range changes. The periods stay the same. Domains stay the same. My x-intercepts, there are none. My y-intercept is what? This is a sine graph. All it moved was 3 up. We agree? What was the original y-intercept at? 0, 0. I now moved 3 up. What's it going to be at? 0, 3. I didn't have to plug this into my calculator at all. How do I find max and mins really easily off of equations? Do we remember from yesterday? How do I find max and mins really, really easily off of equations? I take my D line, my D value, and I add to it my amplitude. And to get my min, I take my D line, my D value, and I subtract my amplitude. I did it by the graph over here. I did it by a little sketch. But you can do it with words too. So it's D plus amplitude. You need to remember these, guys. D minus amplitude. Now, why do you need to remember this? Okay, I give you the equation. Y equals smiley face. I did this for the other class. Can't remember what the letters were. Sine. Sad face. X minus balloon. Plus heart. What's my range? Heart, because it's going to be D. So heart. Whoa, really wonky heart. Plus smiley face, because it would be the absolute value of smiley face, which would keep it a smiley face. Too funny. And then D would be smiley face minus smiley face. So my range is easy. My range is Y such that heart minus smiley face. Smiley face. That is so not a smiley face. It's just maybe because this is sad. Smiley face is less than or equal to Y is less than or equal to heart plus smiley face, YER. My point is, if they don't give you, numbers, if they just gave you variables, they're not going to give you smiley faces and stuff. That would be funny. But they're not going to do that. But if they give you variables, you can answer this, right? So what a lot of people do is they forget the D plus amplitude, D minus amplitude, because what do? Okay, I need the maximum. So I get in my calculator, and I do second trace max, left bound, right bound, maximum, left bound, right bound, minimum. Great. Except my equation is Y equals negative A sine B. Oh, what? Okay, I'm going to put an A in. I'm going to put a B. No, you can't do that. Okay? So you need to know your rules. Okay. What happened to this one? It's going vertically translated to down. What's my range? What's my minimum? My minimum is my D value, -2, minus my amplitude, which is 1. So my min is at -3. It makes sense. Here's my Cartesian plane. My midline is now at -2 because it's normally at 0. It's been moved 2 down. So my midline is here. This is my midline. It's at Y equals -2. I go up 1 to get my max, and I go down 1 to get my min. So my min is at -3, which makes sense. And my max is going to be at -1. And my range is easy. Min to max. -3, oops, square bracket, -1. Or y such that, -3 is less than or equal to y is less than or equal to -1, YR. Do you know how many people put the brackety ones, the interval notation, -1, -3? They're like, -1 must be smaller than -3 because 1 comes before 3. No, 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 bad. Okay? We need to make sure you're getting X'd. Make sure that you don't do that. Okay? 3. What's my translations? Vertical stretch by a factor of 3 about the x-axis. Are you allowed to use short form on tests? No. Are you allowed to drop off about the x-axis because you're not sure which axis? No, that would be really silly. Yeah, almost as silly as the balloon. It'd be not good. Okay, that, yes. Okay, and what else do we have? Vertical translation to up. What affects, what changes? Does my amplitude change? What's it normally on a basic coast graph? Sine. We're not in a coast at all. 1. Has it changed? Yes. So this changes. Does my range change? My range is normally between -1 and 1. First off, yes. It would now be between -3 and 3, but I also moved to up. So it's actually between -1 and 5. So my range changes. Do either the vertical stretch or the vertical translation affect the period of my graph? The period of my graph is based on x values, is it not? What's the only thing that affects x? Stuff that's with the x. So horizontal stretches, horizontal translations. Do I have any? No, my period didn't change. The domain, does it change? It's XER. No. The x-intercepts, would they change? I was here, I'm now. Are they going to move? Yes. It doesn't just take a horizontal shift or horizontal translation to move your x-intercepts if the whole graph moves up. Because different parts of the graph will now be covering it, or if the whole graph moves down. Okay? Would your y-intercept change? The graph is normally at 0, 0. I'm going to multiply my y's by 3 and add 2, because remember it's mapping, correct? So if I'm at 0, 0 and I multiply the y by 0 by 3, I still have 0, but then I add 2, so my y-intercept's now actually at 2, so it changed. Yeah. If it was only a vertical stretch and there was no translation, you're going to stretch vertically like this. It wouldn't change your x-intercepts. It would just make it longer. That's going to have vertical translation then, right? So it needs a vertical translation, not just a vertical stretch to change your x-intercepts. If you have just a vertical stretch, it's just making it longer about the same axis. It's not going to change your horizontal movement. If you're above the x-axis, then you have a vertical translation. Because if you're above the x-axis, you've moved up 2 or up 5 or up 7, right? So if you only had a vertical stretch, it's not going to affect your x-intercepts. Your movement is going to affect it. No, yeah, you're always moving the basic sine or the basic coast graph. Okay, so I'm going to give you a few questions out of this chapter, or out of this unit. Tomorrow, we are going to have graphs with everything, all the movements, and we have to come up with the equations. That's when it makes it a bit harder for you guys. This one isn't too bad. I did button the which? What's up? The range of this function? So your max would be b plus amplitude, so 5, and your min would be d minus amplitude, so -1. Because your normal graph would be at 0, 0, up 3, down 3, right? So it would normally be at -3 and 3, but we moved it up 2. So this -3 is going to become a -1. This +3 is going to become a 5. Yeah. Okay. So we're in chapter 5. Now, they call the movement from left to right, instead of a horizontal translation, they call it a horizontal phase shift in this. Yeah. And instead of saying you moved vertically up 3 or down 3, they call it vertical displacement, up 3, down 3. What's the good thing? You see horizontal, you know it's correct. You see vertical, you know it. So they call it a horizontal phase shift, vertical displacement. Okay? You might want to write it down. Horizontal. Sorry? Will they what? Yeah. Yeah. So it's literally just different words, right? Means the same thing. Phase. Phase. No face shifting. That's weird. It's I'm face shifting. I am now have Chelsea's face on my face. Oh, I get it. Yeah, I was thinking like physical face, and I'm like, no, we're not face shifting. That's really creepy. Like face off. Page 250. One to three odd letters. I know that there's such a thing in odd letters, but A, C, E, you can adapt. Okay, we have this fight every day. We're fine. You guys will adapt. Yes.